Elementary Statistics, Math 146. What is statistics? Well, it is a branch of mathematics, but it uses scientific methods. But we use a lot of mathematical formulas to calculate things, to figure things out. Anyway, welcome. I'm Chad Bemis, and I will be the instructor for this course. And let me know if you have questions. Email me, message me in WAMAP. The WAMAP website is wamap.org, but you know that already because you're accessing this video from that site. So anyway, statistics is employing areas of science. A lot of what we do in statistics, we use hypothesis testing. We test hypotheses, just like drug companies do when they're trying out a new product when they want to get it FDA approved. They test out hypotheses. They have a double-blind study with people. People don't know if they're taking the drug or if they're taking a placebo. So this is what we do when we test hypotheses in statistics. But before we can do those hypothesis tests, we have to be able to draw graphs, collect data, process that data. So that's what we're going to be talking about in the next few modules. Some examples of variables. We want to talk about links, cause and effect relationships between variables, for example, smoking and respiratory disease. There's been lots of evidence, as you know, in the last several years that smoking is bad for you and causes lung cancer, obesity, heart disease, genetic and various diseases. So though we're not going to focus on the science per se, we're going to focus on how those data were collected and what they did with that data numerically and mathematically. So that's sort of the idea behind statistics. The science of gathering, describing, and analyzing data would be one definition, and the actual numerical descriptions of sample data would be another description. I will also include these PowerPoints as part of the course, so if I go on to another slide, like, I don't know, that, and you wanted to go back, you could always go back and use the individual PowerPoints yourselves. Individuals and variables, any set of data containing information about some group of individuals. Okay, so what do we mean when we say individuals? They can be people, yes, and often are. The data we collect is about people: sex, date of birth, address, prescriptions, allergies, weight, height, other things that it's included in the SOAP notes from the patient history and physical. A given characteristic that varies between the individual would be what we mean when we say a variable. And the objective of the study is to collect that data for all of the patients involved. So if we're talking about clinic or hospital patients and we collect that data, sex, gender, date of birth, and so on, then we can collect those numbers, put them in a spreadsheet, say maybe Excel. When we put those numbers in Excel, we can do things with them. We can find the mean. We can find the median, mode, and so on, right? So that is what we're going to talk about at the beginning, but we're also going to broaden the perspective. We're also going to talk about hypothesis tests. If we have this particular information that we've collected from the people, what can we glean from that, right? What can we do new or different in the future that will change the way that our hospital or clinic runs? Okay. So ask yourself the questions when you're planning a statistical study. And one of the things you're going to be doing in this class is you're going to be doing group projects where you will plan your own statistical study and ask your own questions of either your patients or the public. So who am I interested in talking to? Who do I want to find information about? First of all, you know, what individuals are the data describing? Am I interested in finding out from, let's say, a population of my patients who are trying to lose weight, right? Who am I going to do that with, and what do I need to know from them, okay? So what kinds of variations and variables appear in the data? So this would be something that you've done if you do a before-after study, right? Oops, I missed the T. So in other words, you know, John Q. patient weighed 180 pounds before, and then lost some weight, and now he's 165. What does that show? Or more specifically, we have 50 patients doing the before and after study of the weight loss program. Was the weight loss program effective? Things like that. Okay, so the statistics helps you prove your case beyond the shadow of a doubt, as they say, but it's a lot stronger than just saying, well, I think that it worked. You know what I mean? So the statistics. And why? What purpose did the data have? What's the point? Why are you gathering that data? Do we hope to answer a question? So this is when you're developing your study for gathering data and doing your group project, always ask yourself the question, why am I doing this? And sometimes you may change something about the study if you decide, you know what we're doing is not powerful enough, we need to change it. So what are the types of variables? Well, there's two main types. We have categorical, and then we also have quantitative. Categorical does not always mean non-numerical, and quantitative does not always mean numerical. Sometimes they slip over the line and one means the other. So for example, so if I say qualitative, categorical, we're talking about the same thing here. Okay, so categorical can be labels, descriptions of traits, qualities, okay, eye color, drug allergies, drug prescriptions, and so on, right? And they can involve numbers, but numbers that describe non-numerical traits, in other words, not measured. In other words, we cannot compare the two things, even if they're numbers. So think about someone's social security number. If I have 1, 2, 3, 4, 5, 6, 7, 8, 9 is John's social security number, and Sarah's social security number is 0, 1, 2, 3, 4, 5, 6, 7, 8. Does that mean that John's social security is better than Sarah's? Well, no, it just means that that's the identifier for that person. So this would not be quantitative because we cannot measure these things and we don't compare them. How about an ICU ER room number? A room number is an identifier for how to get to a place. If a sign is not present, but there's a number on the door, and there's a door that says, you know, door room 5, then we know that we're entering room 5, and that has a meaning, but it's not better or worse than the door to room 3. Okay? Newborn infant ID tag number. Now, there may or may not be some significance there, but say if there's an 8-digit ID tag number, that is an identifier for that infant. So what is quantitative then? If categorical is, you know, types of descriptions and not measurable, well, what would be some examples of quantitative variables? So think for a second, what would be some examples in your field of study? Maybe weights of newborns, ages of newborns. What else? Maybe length or height. Do they say length or do they say height? Maybe you can teach me. Anyway, so now in weights, most of the world uses grams and kilograms. We use pounds in this country, but kilograms may be used as well. Ages, we use years, yes? Okay. Although with newborns, maybe we use weeks or months as well. Okay? But these are all quantitative variables. Height, again, inches or centimeters, or possibly feet if we're talking adults, right? And I'm sure there's many, many other examples that you could think of. Liquid measurements, cc's, or milliliters of, pick a drug, or how about just H2O, water, right? If I'm administering saline solution, how many cc's, how many quarts, how many liters, okay? Hopefully this makes sense. So this was supposed to be one line at a time, but the way this worked out, it sort of all shows at the same time. But, you know, if I cross that out, cross that out, cross that out, and so on. This is really low tech, so sorry about this. Okay, so the heights of outpatient clinic patients. So we talked about heights. Would this be categorical or quantitative? The flavors of ice cream at a local parlor. The jersey numbers of the Seahawks. Go Hawks. The waiting times in minutes at the nurse's station reception desk. The number of babies that each of the attending OBGYN physicians had delivered this year. All right. So first of all, the heights. C or Q? Q for that one. The flavors of ice cream at a local parlor. Actually, there should not be a dash between ice and cream, but that's okay. Flavors of ice cream, vanilla, chocolate, that would be categorical. The jersey numbers of the Seahawks. Now, this is interesting. So 12 would be the fan jersey. Russell Wilson is he 7? Anyway, so does that mean that the fans are more important than Russell Wilson? Probably not. But more importantly, these are not comparative, right? So it's still categorical. The waiting times at the nurse's station reception desk, that would be quantitative because we're talking about minutes, right? 10 minutes is waiting longer than waiting 5 minutes, which is waiting longer than 1 minute. So these are comparative, and they can represent numbers on a number line. The number of babies that each of the attending physicians has delivered, those are counts, 10, 20, 15, and so on. That would also be quantitative. So graphs. What do graphs do for us that just looking at data do not? Well, it's easy to look at. It gives you a snapshot of patterns without having to dig through a bunch of numbers, and it's also visually appealing. So we're going to look at pie charts and we're going to look at bar graphs. You've seen a pie chart before. You draw a circle and then you have categories, right? So categorical data is often, it's very nicely put in a pie chart. So if we're looking at eye color of infants, you might have blue is the largest category, brown, hazel, and so on. I don't know if there's other eye colors, but how about black and green? Okay, there you go. Anyway, so this is a pie chart and is very easily viewed, and notice that the larger the slice of pie, that means that the larger percentage or the larger count of that variable counted towards that category. Bar graphs usually quantitative, but also can be categorical as well. So first of all, if we have what's called a frequency table, this frequency table has categories listed for types of housing, numbers of students for each of those categories. Now you might wonder, well, where do these percents come from? Well, if you think about, if I added all of these numbers up, 20 students lived in apartments for this college, maybe it's a healthcare nursing college, 15 in a dorm, 9 in a house, or 5 in a sorority or fraternity. So if we add those up, we get 35, 44, 49 total. So that's how many people were surveyed. How did the 41% come about? Well, 41% came about from the frequency living in apartments divided by the 49. So if you do that arithmetic, you should come out to 41%. You can check that. If I divide the 15 by 49, let me erase this little bit here. If I divide 15 by 49, I should get 31%. Remember that you'll get a decimal, and then you convert it to a percent by multiplying by 100. Divide that by 49. So this is where the frequencies, so the frequencies should add up to what percent? That's right, 100%. If they don't add up to 100, then something went wrong. Now what we're doing here is we're actually talking about angles. Angles within that circle. So when I go back up here and you look at these slices of the pie, remember that a circle has a total, or should have a total, of 360 degrees. That's one full rotation, right? So when we talk about, when we talk about the angles for each of those categories, we can at least use that as a guide. So for example, the slice for apartment should be more than twice the size of the slice for house, because more than twice the number of people lived in apartments than houses. Am I making sense? And then so you can use these as a relative comparison, so that when I look at the picture, apartment, dorm, house, and sorority there. So I don't know if you can see the colors here, but this is orange, blue, looks like brown, and like tan, right? So remember I said that the people lived in apartments. The slice should be the biggest one, and it should be about twice or a little more than twice as big as this one, which it is. So this is a quick way of viewing the information given in the table. So that's a pie chart. Bar graphs used to represent categorical or qualitative data, Also, you can use it what's called a histogram for quantitative data. But the height of the bar is going to represent the amount of data in that category, the height of the bar, right? So if you have a bar graph and you have a bar that's height 5, that means, in this case, it means that there were 5 data points or 5 people or 5 whatever that satisfied that category. If I have here this bar is a height of 7, that means that there were 2 more in this category than there were in this one. Okay, the vertical axis is the frequency, counts for that category, and the width of the bars is meaningless, right? The width itself. It's just so that you need to have it wide enough so you can actually see it, but it should be uniform. So try to keep the width the same throughout. So here's the table we gave once again. So then if we were to arrange this in a bar graph, what would the height of the apartment category be? That's right, it would be 20. What would the height of the dorm? 15. And the house and the sorority and frat. So you can imagine what the bar graph would look like given the heights of each of those categories. It'll look something like that. So there's your 20 for the apartment, 15 for the dorm, 10 for the house, and 5 for the sorority. This concludes this PowerPoint. And again, please let me know if you have questions, comments, suggestions, and I welcome your input. Thank you.